All right, welcome back to AP Physics 1. Unit 6, still talking about this energy and momentum of rotating systems. This is topic 6.5. Here we're going to talk about rolling. More specifically, something known as rolling without slipping. So when we have an object that is moving or rotating and moving linearly, it'll have both of those kinetic energies. So it'll have the translational kinetic energy, which is the 1/2 mv squared, but then it'll also have the rotational kinetic energy, which is that 1/2 I omega squared. So it's saying that the total kinetic energy for the system is going to be your translational kinetic energy plus your your rotational kinetic energy. So that 1/2 mv squared plus 1/2 I omega squared. But remember, you can write I on omega in terms of m and v. So when we talk about rolling without slipping, really what happens is the top of the wheel is, or of the object that is rotating, is going, as you can see here, going double the speed. Okay. The center of mass is going to kind of be the key thing, right? That's going to be moving at just the r omega. But interesting point right here is at the bottom, it's actually going to stop. And that's where you get all this interaction with the road or the surface. But as you can see, we decrease as we go down the object that is rotating. So when we talk about rolling without slipping, our usual relationships that we talked about in Unit 5 are going to hold true. So the center of mass is going to simply do our r delta theta rotation. The velocity of the center of mass is just simply going to be r omega. And the acceleration of the center of mass is just going to be r alpha. Remember, these are the three relationships between linear and rotational quantities that we talked about in Unit 5. So when slipping, the motion of a system's center of mass and the rotational motion cannot be directly related. Now, when a rotating system is slipping relative to another surface, the point of application of the force of kinetic friction moves with respect to the surface, so the force of kinetic friction will dissipate energy from the system. Okay, and as you can see, again, like the interesting point is right here, right? It's actually that this friction is what keeps that object rotating. So at the bottom, right, where it makes contact with the surface, that object is not moving. Okay, just for that split instant, because it's still rotating. Right. And so as it rotates at that point of contact, it is not moving for that split second, and then it continues to move. Okay. So let's look at an example problem. So we have at time t equals 0 seconds, a solid disk of radius 0.5 meters rolls without slipping across the floor with a constant translational velocity of 4.5 meters per second. What is the speed of the rotational speed of the disk as it rolls? Okay. So again, they give us the caveat that it says it rolls without slipping, which tells us that the velocity of the center of mass is just simply r omega. And that's what this is right here. Okay, so we want to find omega though. So we're going to do the velocity of the center of mass divided by the radius. And so we have 4.5 meters per second over 0.5 meters. And that's simply going to be 9 radians per second. So this disk is going to rotate at 9 radians per second. Again, this is a very simple example, but again, like if you look at the question, it actually tells us that it rolls without slipping, which allows us to say that the center of mass will travel at the 4.5 meters per second, and then we can figure out the angular or rotational speed, angular speed. Okay, so we're about ready to finish this unit with the next topic of satellites as they orbit.